Hello, I'm Snædís. I'm from the Lab of Magnetic Resonance at DPFL, and I'll be talking about solid-state NMR and hyperpolarization of inorganic materials. Solid-state NMR is a powerful structural probe, but one of its main limitations is low sensitivity. And if we take 6-lithium and lithium titanate as an example, it doesn't have a very high natural abundance or gyromagnetic ratio, and on top of that, the 6-lithium relaxation rate is over 3 hours at room temperature. And the NMR spectrum after 8 hours looks like this. It has a signal-to-noise ratio of about 10, so there's definitely room for improvement. So the question is, can DNP be used to increase sensitivity of inorganic materials like lithium titanate? So let's take a look at how powdered solids can be hyperpolarized, and in general it goes something like this. We have a sample particle that is coated with a wetting phase that doesn't dissolve the particle, and this wetting phase contains radicals, and typically these are nitroxide biradicals. The system is then irradiated with microwaves, which induces transfer of polarization from electrons to protons in the solvent. Spontaneous spin diffusion then distributes the hyperpolarization around the sample. Spin diffusion works kind of like heat transfer. It wants to equalize the polarization in the system. And if there are protons in the bulk of the solid, this works very well, since homonuclear spin diffusion is mediated through dipole couplings. And the dipole coupling strengths depend on gyromagnetic ratio and the density of spins. But often inorganic materials like lithium titanate don't have protons in the bulk, so what are the options? Can the slow lithium spin diffusion efficiently relay hyperpolarization into the bulk? And the short answer is yes. So here are two schematics showing the process. The top one is based on direct DNP, where polarization is transferred directly from radical electrons to low gamma nuclei near the surface, and then slow spin diffusion transports it into the particle. The second approach is a bit different because it's not probing the same part of the sample, and in this case the surface is being selectively hyperpolarized with cross-polarization, but in both cases the sensitivity of the 6-lithium spectra are improved as compared to a reference sample without DNP. And the y-axis here is based on signal-to-noise ratios. The third approach that I want to show is multiple contact CP. It's another way of driving polarization into the bulk. Each CP contact hyperpolarizes the surface and is then followed by a delay that gives slow spin diffusion time to relay hyperpolarization into the bulk. And the pulse sequence is shown there, but the cartoon also explains what's happening during the sequence. But basically it works and it gives an increase in sensitivity of a factor 55 for the bulk. So in summary, a combination of impregnation DNP and slow spin diffusion can be used to increase the sensitivity in NMR of inorganic materials. And with that, I'd like to thank the Amsley group at DPFL, the people that worked with me on this project, and then you for listening.